In the previous unit we learned a bit about types of computers and got a general idea of how a computer works. In this unit we are going to get to understand the computer better. The computer's brain is the CPU, and as we know, it is made up of the ALU and the CU. All the computation happens by using a combination of these components in the memory. In the coming screens we will be focusing on the CPU, its components, along with the memory and its workings. Let's begin with the arithmetic and logic unit. It is the mathematical brain of the computer and a thing of beauty. It is made up of two sections: the arithmetic section and the logical one. Each section contains complex electrical circuits based on which arithmetic operations, add, subtract, multiply and divide, and logical operations, and, or, not, XOR, are carried out. Upon direction from the CU, the correct circuit is employed to perform the operation. Overall, the ALU looks something like this. A and B are values which the operations are to be done on. C represents a space that is created in the memory to store the result of the operation. The values A and B are sent from the memory to the ALU along with data regarding which operation is to be performed. The ALU accepts A and B, executes the instruction and saves the answer, and C. This answer can now be shared with the user by using the output devices of the computer. Next up is the control unit, CU. The job of the control unit is to ensure that all the components are performing the correct operations. The CU reads and understands the instructions. Then it sends inputs and directions to the various other components to do the actual processing. The control unit is the conductor of the orchestra. Instructions can be fetched from the secondary memory or can come directly from the user. These are loaded into the memory sequentially, like the steps in the diagram. From here each line of instructions is first decoded and then the execution begins. Directions are given to the processing components of the computer. For example, A and B are being sent to the ALU and the memory is being asked to create space to store the resulting value C. The computer has a section called storage to store data, programs and files. When required, this information is searched for and pulled from the permanent storage. It is replicated inside the temporary storage called the RAM memory. From here, each sequential instruction is loaded into the CU, which then executes it. There is a section of memory called the ROM. It is a permanent memory containing vital instructions. These two are loaded into the temporary memory for execution. There are different types of ROM. Some are hardwired and cannot be changed, like the MROM or masked ROM. Others, like the programmable ROM, PROM, erasable and programmable ROM, EPROM, and the electrically erasable and programmable ROM, EEPROM, can be modified once or multiple times. There is another type of small memory in the computer known as a register. The CPU as a whole contains multiple registers in order to fetch data from one component like the memory and post it to another component like the CU. Decode, interpret instructions. Execute, executing register usually help in storing and transferring the results of operations performed by the CPU. Think of registers as little helpers that run around doing small but crucial work. Thus, there are different things a computer needs to remember and understand in order to carry out each and every task. Secondary storage consisting of programs, data and files, usually in the form of a disk drive. Primary storage or volatile storage including the RAM and registers. ROM made up of permanent vital instructions that need to be used from time to time. We have learnt a lot in this unit. Congratulations! You have understood, conceptually, how a computer is built. Let's revise quickly to make this memory permanent, pun intended.